How you doing? Welcome back to the show. Sean Tech here. I'm going to connect up my ESD wrist strap. It is time to put down the microphone and hopefully not screw it up or anything like that, although you never know when it comes to doing silly little things like this here. So I've got the microphone and the microphone pad connection that's kind of sitting right there. Can you all see that okay? It seems like that's a little bit, can't tell if that's just me or if that's a little bit blurry on my side of it there. I can't quite tell. Now, the bottom two pads of U1, which is my microphone chip, are actually connected together as ground. If I were to flip the microphone over, I can see that the bottom two pads on the bottom here are also connected up together as well. And so what I'm going to do is flip the microphone back over again. It's going to be attached with the hole that will be sitting on the top part of the pads there. We're going to do this kind of similar to how we did it in the first video where we attached this down. First thing I'm going to do is I'm going to tin all four pads of U1 using my soldering iron. I'm using my T15 soldering iron because at some point after this microphone, if this microphone gets attached, I am going to be attaching the battery after this, and it tends to work better to have a, you'll see the battery clip here in just a little bit is quite a large connection in terms of where it is. So just apply, put down a whole bunch of fluxing agent, what that looks like there, right? And then come on into, zoom into U1. There we go. And we'll activate the flux using soldering iron that's set at, that seems like that's a lot. That's okay, though. The soldering iron is currently set, oh, geez, that does seem like that's an awful lot. Excuse me, can I come in and take some of you? Can I borrow some of you? Is that okay? It seems like, here, I'll just kind of run over all four of you. Yeah, there, even Steven. Do you know anyone named Steve? Tell me about that in the comments, because that did you expect me to say something like that? I'm sure you didn't, or anything along those lines. Now I'm going to grab a Q-tip on here. That's hopefully not the one I was using to play around in the dirt with in an earlier video that I had there. There we go. I'm going to clean up the surface of the microphone pads, kind of like I am right here. There we go, nice and cleaned up using a cleaning agent to clean off the residual fluxing agent, which will be kind of around that area there. And now apply some fresh fluxing agent down to all of the pads, because now it is time to try and attach the microphone using a hot air station. Now I'm going to set the temperature of my hot air to 300 degrees C with an airflow of about, let's just put it at 85. 85 sounds like it's about right there. This is one of those, it's not entirely an exact science with that, something that takes a little bit of some practice here and there. My left hand is going to be controlling the hot air pen. My right hand is going to be holding the microphone chip steady against the pads. Let me try and move that to it here. So I've got the microphone chip here in my tweezers, all right? And so the first thing I'm going to do is hold it there against the pads. I'm going to come over with my hot air pen. I'm going to preheat my board, which is going to, I'm going to try to keep this all on screen here. There we go. So I'm kind of applying at about 4 inches away. I'm applying, there is a hair in my fluxing agent. Boy, that is actually, that is not pretty. Let me try and grab that guy. Get out of there. What's a hair? What's a hair doing with it on there? Whose hair is that? Whose hair could it be? It's mine. So it is. All right. I've got the microphone out. Now I'm going to come on in. I'm going to heat up the pads of the... Oops, that may be moving around just a little bit there. I'm going to heat up the pads, attach the microphone circuit there, and let that kind of cool itself down. Now, I just did notice one of the, or maybe, I'm not sure what capacitor that was. I have a spare capacitor that just kind of is floating around. I'm not sure if that just came from me just bumping things around. I think that came from me just bumping kind of some things around with it there. There we go. Gosh, I kind of wish in design mode that those pads could be just a little bit better in terms of where those are. But that does looks like it's been attached correctly. Not the best in the world, but it at least it does look like it has been attached on it here. What we might wind up doing here is might heat that up just a little bit more If this does not work, we'll try the basics. We just want to see if the basic parts of this circuit work. We'll do the nudge test. The microphone is not nudging from its place, so that's kind of a good sign to it there. Okay. So the last thing that we need to connect is actually on the back of the circuit board, next to the Zelda map, is what that is, and that is the battery clip. The battery clip is the by far largest part of the circuit board. It's this giant honking piece of plastic right here. This battery clip is polarized, so there is a polarity marker for positive here on the silk screen and negative here on the other side of the silk screen, which actually, and one word to look carefully, there is a chamfered corner of the battery clip. This actually does very much have to do with how the battery clip is going to be attached to this here. You see that? See that? There's a little chamfered edge. Oh my goodness, my battery clip is going supernova there. Sorry about that. Excuse me. Sorry. All right. So anyway, that's pretty darn bright. The way that we're going to attach this battery clip is what I'm going to do is I'm going to use a helping hand that I have kind of off screen right now, with some alligator clips attached to the helping hand. I'm going to kind of help to hold this guy in place. Since this is a larger type of component, I might actually have to press into the board slightly, which is going to make it to where, since the board has all the other components onto the other side, it's going to make this a little bit sort of lopsided, if you will. Using my larger soldering iron set to 640, my T15 bent tip soldering iron set to 640 degrees Fahrenheit. I'm going to apply some fluxing agent down to the pads, and then attach a whole truckload of solder. I'm going to really mount that guy up pretty darn nicely to it here. And then using a larger pair of tweezers in my right hand, I'm going to take the battery clip, and what I'm going to do is I'm going to let it sit inside the molten solder for just a little bit. Do you see that? Do you see how it started kind of tinning over the top part of it here? Oops. Hey, I'm working at sort of an angle right now. Oh, no, you don't. No, you don't. You get back there. Again, it helps to work sometimes as flat as you can possibly get some things, but that's not always possible. Now, I am making sure I'm putting this down, observing the correct polarity of the chip component. So I'm going to try to take my soldering iron away at this point and let that kind of see if that sticks there and holds. It sure looks like it did. I hope that caught on camera as well. There's the one side of it down. I'm going to move on over to the other side of a song. There it is. There it is. All right, there's the other side of it. It's a little bit bent, but that's okay. Applying some fluxing agent onto this side here. Actually, what we'll do is we'll zoom in on this one here so you can kind of watch the solder flow over onto the battery clip pad. Can you all see that okay? Okay, so I'm going to come at the soldering with the soldering iron on the right hand side and solder coming in from the top. Heat up the fluxing agent, which activates it. And now I'm going to apply some solder, a generous amount of solder down to this pad. I want that to be a mechanically held joint, is what I really want that to be. That is a very large amount of solder that's been applied down to that pad. I'm actually going to now reverse that, and the reason I'm applying such a large amount down to the pads is because this is going to have a battery that is going to be forcibly, put into here and potentially even replaced from time to time as well. Connectors often require a lot of additional connections to it to make sure that they are additional solder and or other mechanical stabilizers to make sure that they are effectively connected up to the thing that they need to be connected up to. Okay, so now I guess it's time for a demonstration that it works, so to speak. Do I have a battery somewhere? Maybe somewhere here, there, yes, no, yes, no. I think I got one. I got one sitting over here somewhere. Are you one? Are you one? Can I have you? Can I have you? It's stuck. I'm trying to take another battery out of another device to it here. Here is my battery. I'm gonna put it on the inside of the battery clip. Whoops, as hear that kind of snap into play there. I did see a light turn on very quickly. And now the moment of truth. So, okay, there, zoom in on the LEDs. So, if I hold the button down, I do a little bit of some, I'll turn on the lights just a little bit here. Testing, testing. 1, 2, 3. Whoa, there's a little bit of a. We're getting close. A little bit of a talking. A little bit of a normal talk. It works. Hey, how about that? How about that? That's pretty awesome. That's kind of and it looks a lot brighter if I'm doing this like right in front of the camera. I don't know if you can see this now, but it's definitely there. It's bright. It's working. So hey, that's a working circuit. Now sometimes that doesn't happen every single time. Sometimes this every once in a while you're building circuits and it that doesn't always work right away with it here. That may be something that we look at in some other videos in terms of how that works. But yeah, that is the Pole's voice efficiency detector is what that is. How do you think that looks? I'm probably screaming into the microphone. I'm sorry, folks. That's probably this probably is working pretty nicely, is what that is. So it does work. It's kind of a neat little circuit. We can kind of toy around with things a little bit on here to get things to work in better or worse ways. So what do you all think? Did you find this project kind of interesting? Maybe we'll come back and do a little bit of some troubleshooting at some point here as well. So thank you very much, everyone, for coming along with me for this sequence here. Hopefully you got to see all the cool parts of how this circuit kind of works to it there. So thank you very much, and we'll see you around for the next project to it on there. All right, thanks, folks. All right, bye-bye.